Okay, you guys. So, module four point part two. We're talking about measures of. So you guys should have been learning about these almost probably your entire mathematical career so far, and we're going to talk about the mean, the median, and the mode. When I used to teach this to sixth graders, there was a song that we used to sing to the tune of row, row, row your boat, I think it was, let's see, the mode's the most, the average is the mean, merrily, 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 the median's in between. I'm not sure if the merrilies were there. I can't really remember right now, but some of you may remember that if your teachers did the same thing. So this professor who created these notes is very excited that we're going to mention some Greek letters. And actually, as a mathematician, as of having years and years and years of mathematics classes, it is cool that we learn a lot of Greek letters. So let's go through, if we're talking about the mean, let's go through and see what these notes are telling us about the mean. Okay. The first measures of center tool. To find the mean of a set of data, you simply add up all the numbers and divide by how many data values you have. Okay. We usually refer to it as the average in everyday lives. I try to stick with the mean since that's the mathematical term. N. Okay, so this first letter N, not small letter N. This is not a Greek letter. This is, I guess we use the Arabic alphabet, don't we? Somebody might know a little bit more about that than I do. But a small n, this is talking about the sample size. How many data values are in that sample? So if you remember from module 4.1, we talked about test scores of 20 students. The sample size would have been 20. Our n from that would have been n equals 20 students. Okay. Not to be confused with capital N, which is the population size. Okay. So the difference between a sample and a population, it depends on what you're talking. We'll get into this later, but just quickly, since they're using that vocab right here for the mean, let's say we're talking about a specific school. I teach at DCIS, so I will use that. So let's say that my population are students at DCIS. Okay, that would be the population. And let's just say that my sample are 20 pre-calculus students. Okay, so the sample is going to be a subset of that larger population. Okay, let's skip for now this next one. I mean, we can read XI denotes the ith data value. I know it sounds really weird, an index counter for our data. We are not really going to use this during this class, maybe a little bit in module 14, but we'll kind of put it off. You don't need to know it for this first exam, so don't over stress your brain right now. Here, this is a capital sigma. We will start to use a lowercase sigma also. This would be a lowercase sigma. I know it doesn't really look like it would be a lowercase of that, but it is. But here's the capital sigma, and it is a summation. This means that we add everything after it together. So like it says here, sigma x means the sum of all x. In this case, the sum of all of our data. All right, this next one is an X with a bar on top of it, and you literally read that as X bar. That's how you would say that, X bar. We will be using this a lot. It represents the sample mean. So if you look up where I said above that our sample was those 20 students that had test scores that we were looking at, X bar would have been the mean value for those 20 test scores. Okay, and here we have mu. Okay, read mu. It kind of looks like mu, but it's not, it's mu. And it represents the population mean, okay? So instead of just looking at those 20 students, what if everybody at the school of that population I was using had taken that test? Mu would be the mean of everybody at the school taking that test as opposed to those 20 students that we were looking at. We need, and this does become important, especially later on in this course, the difference between X bar and mu. And then it just wants us to think about the mean is sensitive to extreme values. So the way I like to talk to students about why the mean is so sensitive is if we talk about household income. And if you've heard, maybe in one of your social studies classes, maybe you talk about the median household income, and that's the way we talk about it in the United States. It's called the median household income, okay? And the reason why even though we haven't learned about the median, that's like coming up in 5 seconds, the reason why we use median to describe household income is because the mean would be too sensitive, exactly like it's saying, to that number. So let's say in the United States, what's the smallest amount of money that somebody can make? And let's just say 0. Let's say somebody doesn't make any money, a student, right? 0 money. And then let's talk about the richest man in the United States. What that household income would be Jeff Bezos, and he would literally be billions of dollars. And I don't even know off the top of my head. Let's just say, I really think it's in like the hundreds of billions of dollars, but just for clarity, let's just say 100 billion. Okay. And then there's everybody, this is a continuous value. Everybody in between is making somewhere between 0. In the United States, you are making somewhere between $0 per year and $100 billion per year, right? And somewhere in the middle, there's going to be that median. We'll get to that in a minute. But let's talk about the mean, okay? The mean, what's going to happen is, let's say from 0 to the middle, let's say the middle is like, let's do $60,000, okay? Half of the people are going to be between 0 and $60,000. The other half of the people are going to be between $60,000 and $100 billion, okay? Now, the reason why mean is sensitive here is because between 0 and 60,000, how many numbers are between 0 and 60,000? Only 60,000 numbers, right? How many numbers, not people, remember it's the same amount of people, but we're talking about how many numbers between 60,000 and 100 billion. Well, I can't even do that off the top of my head and give you a great answer. But billions of dollars, $99 billion, $99 billion in between 60,000 and 100 billion, okay? That's gonna skew, if we used the mean, because this is so much farther, so I drew this wrong. This is why this isn't a good way to look at this for you guys. I drew this wrong. Because we're talking about those dollar values, we have somebody in the United States making 0. And then between 0 and 60,000, this will make more sense to you guys. Between 0 and 60,000. Let's say that's our median. I'm making that up, but I think it's close. Half of the people are between those two numbers. Okay. The other half of the people, and this isn't even right, this isn't even correct, but this is just how far I can get on this page. 100 billion. Okay. So half of the people are scrunched up in here, but the other half of the people kind of get to spread out. If we took the mean value, because this is so much bigger, our mean value would be way up here. If we used the mean household income to describe what people make in the United States using Jeff Bezos's household income, it would look like we were all millionaires, if not billionaires, because that number would be so high if we kept him in our data to find the mean. Okay, it would make it really high. Whereas the median is just exactly half the people make more than this, half the people make less than this. So when it's talking about the mean being super sensitive, that's what it means. Okay. And right now we're gonna see it in this smaller, we're gonna see exactly what I was talking about, but in this smaller kind of venue. Okay, so here we want to find the mean of this sample of 6 students and their test scores. So I want to teach you how to do that on the calculator really quickly. I know this looks, I couldn't figure out, I told you my trial ran out, so they like gave me just the bare bones. So here's what I want you to do. On your graphing calculator, on your TI calculator, I want you to hit the stat button. Okay, I just turned it red, the stat button. And then you're going to hit enter. And it's going to bring up our lists. I'm going to call these L1, L2, just like they're called here. If you need to clear them out, you can arrow up to, you can arrow up and clear it out. Okay, since I don't have anything in there, it's not really working for me quite that way. But let's enter in this data. So we have 69, 72, 81. So 69, 72, 81. And then the last 3 are 83, 91, 72. Again, it doesn't matter that they're not in order. That's fine. And then I just forgot 83, 91, 72. Okay, so I've entered in those 6 data points into list 1. Now I'm going to go back to stat, and I'm going to right arrow over to calc. And we have one variable here. We have test scores. So we're going to click on one variable statistics. That's what that stands for. So I'm just going to hit enter. Enter on the calculator. Okay, I am using list 1. I do not need to use a frequency list here. We'll get into that later. I'm going to hit calculate, and it'll bring it up. So we are looking for X bar. It's the very top. The mean for this data is 78. So my calculator added them all up and divided by 6, and it got 78. You could have just added them all up, divided that answer by 6, and you should also get 78, but I wanted to teach you how to use this. If you follow along with me here, what we just did, there's a bunch of stuff. So here's that sigma X right under, so it added up all the test scores. If you add up all the test scores, you get 468. If you square all the test scores first and then add them up, that's what this means. You're going to get 36,860. Here we have standard deviation. We'll get to that tomorrow. Don't worry about that now. Standard deviation of the population, standard deviation of the sample. N is equal to 6. That is our sample size. That is how many test scores we are looking at. Then we have our minimum value is 69, our quartile 1. Again, we'll get to this later. Our median, 76.5. That's on the next page. quartile 3, and max. So when you do one variable stats, you get a lot of information back. Okay, and that's why I wanted to show you that. So finding the mean gave us 78 for this data here. Okay, so it says now actually imagine we have 7 students, but we have 1 student that didn't take the exam, so they got a 0, right? So how will that change the score? So let's go back and look. When we added all of these numbers up, it was 468, okay? So when we took 468 and we divided it by 6, we got 78. What this is saying is if we add 0, if we add another number 0, we still get 468, but we actually have 7 students. So when we increase that denominator, okay, it's going to decrease our overall mean. So we're going to take 468 and divide it by 7. Let's see, let's go back to the regular calculator page, and I'm going to do 468 divided by 7. And so if somebody got a 0, that's going to drag our score down to our mean score down to 66.86 approximately. So you use approximately when you round because it's not going to be an exact answer. Okay, so that 0 brought the whole mean down. All right. So that's what it wanted here. So in this case, 66.86. Okay. So is the mean a good way to determine the value of the grade? In this case, I think that that's written kind of funny. I think what it wants to say is if you looked at the mean of a set of data, would it be representative of what a student might get on the test? And in this case, it seems like it might not be, because it dragged it down from everybody in my, like, oh, Miss Binkley, her mean score is 78. Well, that means, you know, that my average score is going to be almost a B. Whereas if one student kind of dropped out and didn't come back, it drags it down to, you know, if you take Miss Binkley's class, you might get a D. That's her average score. So that seems like it might not be a good way to look at our scores, you know. All right, the median is the middle. So we just talked about this a little bit, okay? So what is this going through? Read through it exactly if you want, but you know, you put all of your numbers in order and then you count up halfway through. But, and I talked about this, I think in our last video, if you have an even amount of numbers, if you count halfway through something, what's going to happen? If you count halfway through, if we look at these set of test data, first, let's put them in order. So 69, and then it's going to be 72, and then 72 again, 81, 83, 91. Okay. If we count halfway through, we end up being right here. So we have 3 data points on the right-hand side. We have 3 data points on the left-hand side. So there is no number in the middle. So in that case, what I highlighted in pink is what we do. And what that's doing is it just means you find the average. You take these numbers, you add them up, and you divide by 2. So my 2 numbers are 72 plus 81. And we're going to divide by 2. And that's going to be, let's see, 3. Let's do this in my head. 8 and 7 is 15. Tell me if I make a mistake. Divided by 2. So half of 150 is what? 75. And half of 3 is 1.5. So 75, 76.5. Maybe, is that what it was? Did I do that correctly in my head? Because we still have our information still in there. It's still on the list, so all I have to do is go back. And our median, 76.5, nice. 76.5. Okay, so if you don't want to go through finding the average between those two numbers that are in the middle, if you want to just figure out 76.5 would be the number that is exactly in between 81 and 72. So finding the mean of those two numbers gives you the number exactly in the middle of them, which is the median. Okay, so this is saying, let's say we have that student again, okay, and they are still not there, so I'm going to put their score 0 on the end. I'm going to do this above since I already have these numbers in order, okay? So what happens? Let's kind of erase what we were doing before. In this case, if I have 7 students, if you have an odd number, you are going to be able to get a value right in the middle. So here, let me highlight 72. I'm highlighting 72 because that leaves me still 3 numbers on the left-hand side and 3 numbers on the right-hand side. So 3 numbers above 72, 3 numbers below 72, but there's an actual number there. I don't have to find the average. So it is less, right? If I have that student that gets a 0 and I have that median value, the number is still less. That student getting a 0 brings it down, but it doesn't, my new median is now 72. It doesn't bring it down as much as when we were looking at the mean. Remember, the mean went down like 2 whole letter grades, right? This didn't even go down 1 letter grade. So that's what it meant. That's what these notes were talking about when it meant that, or I'm sorry, when it said that the mean is more sensitive than the median, okay? In both cases, we have 6 elements before mean, 3 and 3. Okay. So mode's the third measure of center, and the mode is just the number that occurs the most often. So in the data above, the mode would be 72, okay? Because that's the only number that happens twice. So we say the mode is 72. If there are no, this is important, if there are no repeated values, then there is no mode. But interestingly, let's say we also had 2 91s. What we would say, now we have 2 72s and 2 91s, we would say that it is bimodal. Okay. I'm not sure if I spelled that correctly. I feel like it should be maybe an A. Okay, so, it can have multiple nodes. That's what it's saying. If it has, 2, it's bimodal. If it has 3 that are the same, you could call it trimodal. Unlike the mean and the median, which can only be used for quantitative data, mode can also be used to describe qualitative data. Well, that makes sense, right? Because you could say the mode of A's, you could have a mode. What was the mode of our test scores in 4 part 1? It was C. We had the majority of C's, right? So the mode there was C. That's the one that occurred the most. Okay, and so here we're just looking at some curves, and we're going to get really into this, I think, starting in part 5 of this, but you guys should have been seeing this over the past few years. And this first one here, this is a normal curve, a bell-shaped curve. You may notice that in a bell-shaped curve, and pretend that there's a little histogram underneath it. Okay, pretend we have our little rectangles. That's all a curve is just a bunch. You guys may, if you have had calculus, you'll remember this from calculus, but a curve is just a bunch of our histogram bins underneath it, okay? In a normal bell curve, the mean and the median and the mode are all equal to each other. That's what makes a normal curve, okay? And so let's just write these. And I think this becomes really important on the first test to know these names. So normal curve, okay? Here, this is, let's call this the Jeff Bezos curve, okay? This is Jeff way out here. But right here is our median. Here's halfway through. The majority of people make, or the same amount of people make below here. But see, there's hardly anybody here until you, I'm saying that wrong. It's the same amount of people, but they're stretched out. That's what makes the curve go lower right there. They're stretched out. So it's pulled, Jeff is pulling that data this way. It's pulling it to the right. And we call this curve skewed right. It's pulling it to the right. We call it skewed right, okay? It's the same amount of people below the median and above the median. That's what the median means, but they're stretched out farther on the right-hand side. So in this case, the mean is the largest value, then the median, then the mode is the smallest value, okay? So here it's kind of the opposite of that. In this case, when it's stretched out more this way, right, here, it's lower here, stretched out here, we call this skewed left, okay? In this case, the mean is smaller than the median is smaller than the mode. And it's really important that you remember. I think the test will show you a picture and it'll ask you, is this skewed right? Is this skewed left? Is this a normal balanced curve? And the last part of the notes are just the statistics stuff, or I'm sorry, the calculator stuff that we already talked about. But now you have the directions right here in front of you, so you might want to try that again. And this is it for part module 4, part 2.